Here we go, guys. Here we go. The 3690 and 454590 are in here because, in essence, this is what how we derive the unit circle from these two. In a little bit, we'll talk about where all these things come from. So here's the 30, 60, 90 triangle, guys. Remember from your geometry days that a 30, 60, 90 triangle has these properties. It has n square root of 3, 2n. Those are just ways on how to find the sides of your triangle. Usually in a right triangle, they call this a leg, the short leg, the long leg, and then whatever is opposite your 90 degrees is your hypotenuse. That's common terminology, but you can call them all sides. They're just sides of a triangle. Nothing crazy, right? They want us to find the hypotenuse here. They call that x. So I say, okay, well, right now they give me the 6, which is the long leg. So I'm going to write 6 there for n squared of 3 equals 6. And if I want to get n by itself, because in order to get the hypotenuse, you got to find the short leg and then double it. See, I got to find the n first. So I'm going to write n squared of 3 equals 6. Are we still okay, guys? All right, how do I get n by itself? Yeah, just, no. This is n times square root of 3. Divide by, not by n, divide by the square root of 3, because I'm trying to solve for n. So whatever you do to one side, you do to the other. So I have this answer as 6 over square root of 3, which I guess is okay. It's an okay answer. But if you want to rationalize it, see it says rational denominator. That means that I want to have the square root in the numerator, not the denominator. So I'm going to multiply this sucker by square root of 3 over square root of 3. I haven't done anything. I just multiplied it by 1. Anything times 1, it's itself. So I have 6 root 3 over 3. Are we still okay? Then I see that I have a 3 in the denominator and I have a 6 in the numerator. How many times does 3 go into 6? Yeah, twice. So my answer is 2 root. Well, that's not my answer, but this short leg is 2 root 3. Are we still okay? Okay. All right. I want the hypotenuse. So to get the hypotenuse, I'm going ahead and just double the 2 root 3. So if I double the 2 root 3, it is now 4 root 3. What's up? Oh, whenever you double something, that means you're just multiplying by 2. So I'm just doing this. 2 root 3 times 2. So it's just 4 root 3. See? Are we still okay, guys? Okay. All right. So this. What happened? I'm doubling the 2 root 3 because my property here for 30, 60, 90, it says that my short leg is n, and it says that my hypotenuse is 2n. Well, this right here is n. So in order to get my hypotenuse, I got to double the n, so 4 root 3. Oh, you're good. Mujica? Okay. Don't hesitate to ask, guys. I'm here for you guys. If you guys knew all the answers, then, I wouldn't be needed because you guys know everything. So I do want you guys to ask. If you could read my brain, I want you to ask. Ask me, miss.
I will.
Okay. I mean, ask me like math questions. Don't ask me like, I know a few science. Avogadro's number, 6.02 times 10 to the 23rd. Speed of light, 3.0 times 10 to the 8 meters per second. Planck's constant. Okay, I'll stop. Have you guys done redox reactions and all that? No, but you at least know the difference between ionic bonding and covalent bonding and stuff like that. Okay. All right, let's just continue with this. All right. Are we okay with that, guys? All right, let's go to the next one. It says find the length of side x in simplest radical form or the rational denominator. This is a 45, 45, 90 triangle. So I'm going to write the expression right here. 45, 45, 90 triangle. The expression is n square root of 2. Don't be a robot. Those come from somewhere. So if this is square root of 5, this is also square root of 5. And I want to figure out what the hypotenuse is. So all I got to do is take the square root of 5 and multiply it by? No, not by 5. Multiply by square root of 2. So square root of 5 times square root of 2, they're both inside the radical. So it's the laws of exponents apply. You still have that square root. What's 5 times 2? So you put the 10 inside the radical. So this is radical 10 or square root of 10, whatever you feel most comfortable saying. Did that make sense, guys? All right. Now we're ready for an introduction to the unit circle. Relax. We'll be fine. Ask me, miss. Yeah, you'll be fine. All right, I'm gonna go slow. Guys, you'll be fine. Look, if you talk to my seniors back there, you guys were you guys fine with the unit circle? Yeah. See, it's yeah, it's fine. You're fine. Look, first, what do we know about sine, cosine, tangent? I'm gonna write all we know right now. We don't know half angles. You don't know double angles. You don't know composite argument properties for sine and cosine. All we know is SOHCAHTOA. That's all you know. That's all you know right now. Are we still okay? If I draw a right triangle right here, I'm gonna say this is my angle. In physics, have you guys already talked about horizontal and vertical displacements? Okay. I'm gonna call that x. I'm gonna call this y, and I'm gonna call the hypotenuse a distance of 1. If this is true, then I know that sine of this angle is equal to opposite over hypotenuse, so y divided by 1. So that means that sine is just y. Because y divided by 1 is just y. Did we see that, guys? Okay. If this is true, this says the cosine, it says AH, so that means adjacent divided by hypotenuse. So cosine of this angle is this adjacent divided by hypotenuse, which is 1. So that means cosine is just x. Are we okay with that, guys? All right. Tangent. Tangent of this angle is just y divided by x. We're going to go back to those. So make sure, what would I put in rectangles? Put this in a rectangle, put this in a rectangle, put this in a rectangle. Child, why did you leave all this blank space? Because I'm going to need it. All right, go to the unit circle. I am recording this, guys, so you know you never have to actually write anything down if you don't want to. No, you don't have to. Like, in all my time at YWLA, I think there was at least, maybe Miss Martinez from 2019. She would just look at me, do whatever, and then she would go back and fill it in. So maybe that worked for her. I mean, look, she got college credit. So maybe it'll work for you too. You know, maybe the second viewing when I upload it to YouTube, I upload it daily. My worst case scenario, I'll upload it at the end of the week. But you know, if you have time during your advisory, lock in, put your headphones on, if your teacher allows you to, or a professor or whatever, and watch the video again. And maybe the second time you'll be like, oh, it makes sense now. You know, because you paid. Okay, whatever works for you. Okay, sorry guys, I didn't mean to go off on a tangent there. Off on a tangent. All right, here we go. You guys ready? These are special angles. You see those degree symbols there? That's a degree symbol. So I haven't moved. So on this one right here on the x-axis, that's 0 degrees. The one on the y-axis is 90 degrees. So put 90 there. And these are special angles. The distance between the x-axis and this one there is always going to be 30 degrees. So this one's 30 degrees. The distance between an array, or I guess a segment here, and one of the axes is again 30 degrees. That gap right there is 30 degrees, right? And then the gap between segments is 15 degrees. That pattern is going to be consistent throughout the whole unit circle. So that means this one in the middle here, what angle do you think this one in burnt orange is? 45, because you did the 30 plus the 15. Do you guys see what we did there? All right, what angle do you think this one in blue is? 60. That's 60 degrees. Let me color code it. Do you guys see what we did? Okay. This is called a unit circle. Hint, hint, unit. So that means the radius is 1 unit. So because the radius is 1 unit, look, here's the center, 0, 0. So then that means this coordinate way over here on the x-axis must be coordinate 1, 0. Does that make sense, guys? All right. So that means the coordinate way up there on the y-axis must be 0, 1. Are we still okay? Nothing crazy, right? Yes.
I think just minor confusion. If like the first two triangles equal 45, why are you writing it in the third one?
I don't understand your question. Tell me again.
Okay, so in the burnt orange, the arrow goes across two angles, right?
Okay, 2 seconds. Yeah, the 30 and the 45. Yeah.
So then why are you writing it in the third one? I'm a little lost.
Why am I writing in the third quadrant? I'm in the first quadrant.
45 written like
45 is this burnt orange angle.
yeah, but
So
I'm sorry. Let's just talk about like you wrote it in the third triangle.
because it's unknown. It's this triangle in red that's 45 degrees. So I wrote it. I have a whole bunch of triangles in there, but I wrote it in that second line because it's that 45 degrees indicates that triangle there that you see.
Okay. All right,
Is that your question? Did I answer your question? Okay. Do you guys see the triangle in red? Do you guys see the triangle in... Let's change the color to green. Do you guys see the triangle in green? Yeah, there's triangles all over the place. Do you guys see the triangle in green? Okay, that triangle in green, I'm gonna draw it right here. I'm gonna try to color code it. It's not perfect. That's my long leg, short leg, bam. Here's 30 degrees. Do you agree that the horizontal displacement for the long leg, that the long leg is your x coordinate? Yeah, let me come back over here. Let me go to the smart board. Ready, Pi? Yeah, maybe I said it a little. I'll say it later. Do you agree that this distance from here all the way to here, that is just some x coordinate? Yes. Yeah. So put an x there. Don't worry, I'm going to change it to a real value in a little bit. Do you agree that this is from here, the x-axis right there, right on top of it, all the way to that point right there on that curve, on the unit circle? Do you agree that's a y value? Yes. Okay, by the way, this distance in the math world, in the science world, is called a horizontal displacement. Have you guys talked about that in physics? That just means the net value of this distance here. Take a guess. What do you think that's called? Vertical displacement. That just means the net value. Hopefully you talk about displacement and vectors and scalars and all that, but no big deal. It just means the distance. Are we okay with that, guys? All right. So here it is. I'm gonna type in right here. I'm gonna put an x and I'm gonna put a y, and I can keep it green. You don't have to change it the color there. X and y. And we already said that the radius of the unit circle is 1. So take a guess. That hypotenuse, that's a radius. Do you guys see that? So that hypotenuse, which is a radius, must be 1. It must be 1 because it's a unit circle. Are we still okay? Nothing crazy, right? All right. This is a 30, 60, 90 triangle, guys. There's a 60 up there. So the 60 degrees is this one right here. See? In a 30, 60, 90 triangle, let me write it down. 30, 60, 90. We already said n square root of 3, and 2n. Are we still okay? All right. Well, that 2n, I'm going to put a 1 right there. Chop, why are you putting that 1? Because that's my hypotenuse. So 2n equals 1. My short leg, what's my short leg? My short leg is the y. Do you guys see that? So the 30 degrees aims at the y. And my long leg is the x. Are we still okay? All right. I have 2n equals 1. How do I get n by itself? Divide by 2. Divide by 2. Divide by 2. N equals half. So there it is. I put a half right underneath that. So wherever I have my n, I put a half. So what is the y value? Yeah, 1/2. So I put a 1/2 right here. Use that little dashed line as your fraction there. It makes it easier to write. Do you guys see how we got it? All right. Now, how am I going to get my long leg? My long leg, it says that I take my n and I multiply it by what? square root of 3. So I'm just going to take my n, which is half, and I'm going to multiply it by square root of 3. Here's how UH writes it like this, which is fine. That's fine. I prefer, and you don't have to have my preferences, I prefer square root of 3 over 2. I think it looks cleaner and neater. But if you want to write it 1/2 with a square root of 3 on the side, that is perfectly fine. UH writes it like that. I like to write it like this. Which one do you like better? A or B? It's okay. You don't have to have my preferences if you like A better. The University of Houston quizzes, when you take your UH quizzes is going to have it like that. Oh, you like A better? Okay. Do you like B better? Yeah. Yes. Why am I putting what? Where? Because my radius is 1. My radius is the hypotenuse. You told me right here. See, this says 1, 0. That's my radius from the center. So it doesn't matter where I extend from the center to any point on that circle. The radius is still going to be 1. Well, yeah, that's the definition of a circle, right? Everything's equidistant from the center. So this, I'm not trying to gaslight or anything. I don't know if that even that work right. This is 1. So then this has to be 1. This has to be 1. That has to be 1. That has to be 1 because those are all centers. Those are all radiuses. And it's the same radius of that same circle. Right, Uncle says?
Right.
Right.
I ate that.
I ate that. Now I want pizza. Okay. I'll stop. Hey, when is the senior class going to do a bake sale so I can order some cookies? All right. No, yeah, let's focus, guys. Let's focus. Don't worry. All right. Did I answer your question? Any other questions? All right, here we go, guys. Yeah, you guys were saying that you guys prefer A over B. That's fine. If you prefer A over B, go ahead. I'm going to write it square root of 3 over 2 like that because I think it looks cleaner and neater. If you want to write 1/2 with a square root of 3 on the side, that's fine as well. Are we okay? All right, here we go. You see that red triangle? I'm going to put it right here. 45, 45, 90-degree triangle. That's 45 degrees right here. Here's my right angle. This is a 1 because that's what my hypotenuse is. And I need to figure out what the x and what the y is. I'm going to write 45 degree, 90 triangle, and square root of 2. Are we still okay, guys? All right, here we go. I'm going to put a 1 underneath the n square root of 2. I'm going to go n square root of 2 equals 1. Are we still okay? How do I get the n by itself? Divided by the square root of 2. So I get n equals 1 over square root of 2, which is okay. But we want to have a rational denominator. We want to rationalize this. I hope I said it right. So I'm going to multiply this by square root of 2 over square root of 2. So square root of 2 over 2. If you want to write 1/2 with a square root of 2 on the side, that's fine. But it looks cleaner to me like this. So that means the x is square root of 2 over 2, and so is the y because they're the same length. It says n and n. So I come over here and I write square root of 2 over 2, square root of 2 over 2. Are we still okay, guys? Okay. Yes.
How do you know? Can I see your work? Like, how do we know that n square root of 2 is 1? Like that we have to use.
My hypotenuse is 1. My hypotenuse is always whatever the 90 degrees at. It's n is the leg or the side. This is the side from geometry, right? And then the hypotenuse is n squared root of 2.
So the 1 is always going to be the 90.
Mm-hmm. My radius is 1 for the unit circle. So the hypotenuse is always 1.
But we can use the formula for the 90.
Yes, and n squared root of 2. So the n squared root of 2 equals 1.
Like for both types of triangles.
All right triangles that are 45, 45, 90, the hypotenuse is always going to be whatever the leg is, n squared root of 2, n squared root of 2. So the hypotenuse is n squared root of 2. That's a property that tells you the hypotenuse. And because I told you the hypotenuse is 1, we set 1 equal to n squared root of 2. Okay. Are we okay, guys? All right, guys, there's another 30, 60, 90 triangle in here. Do you guys see it? I'm going to write it in purple. No, not purple. Let's do, what color you guys want? Yellow? Can we even see yellow? Oh, yeah, kind of. Do you guys see that in yellow? but we can see it, right?
I
Sorry.
like
That triangle in yellow is another 30, 60, 90 triangle, guys. But instead, this in yellow, I guess this in blue there was already there. That is 60 degrees. And way up here, that's 30 degrees. Do you guys see it? Because that one in yellow is the same as the one in green. Now my long leg is my short leg, and now my short leg is my long leg. Maybe I said that wrong. Maybe now my new x value, the horizontal displacement, instead of being square root of 3 over 2, now it's going to be a half. They toggle. Because now my x coordinate is the short leg. Do you guys see that? And my y coordinate is my long leg. So now look, this it used to be this distance here used to be square root of 3 over 2. That's up 60 degrees, that's where it is. But now this is 60 degrees, the one in yellow. So now this is my long leg. So that distance is the same as this distance. So that one, the y value is going to be square root of 3 over 2. And sorry, I won't choose yellow again. It looks kind of rowdy. Okay. How do we feel? Not bad? All right, check it out. We finished almost the entire unit circle. Now we need radians. At 0 degrees, that's the same thing as 0 radians. So put a 0 on that blank right there. Chuff, I don't know how to convert degrees to radians. Do you guys remember how to convert degrees to radians? I take my degree and I multiply it by what? Something something over 180.
Oh, pi.
Pi over 180. So here we go. You guys ready? 30 degrees. I guess we don't need a calculator for this one. Here we go. So I'm going to go 30 degrees, and I want to convert this to radians. I'm going to go to pi over 180 degrees. 3 goes into 18 6 times. Leave the pi alone, so this is pi over 6. So at 30 degrees, put a pi over 6. Yay or nay? At 45 degrees, I'm going to multiply this by pi over 180. I know that 45 plus 45 is 90, and 90 times 2 is 180. So 45 goes into 180 4 times. If you don't know that, relax. You're fine. You could just take your calculator and do this. Be careful with it. Instead of going, so let me teach you a hack. Instead of doing this, guys, I know some of you are going to be putting pi like that. Remember, this is not a CAS. If you do that, remember that pi goes on forever. If you do that, it won't tip it to you in terms of pi. You know, if I try to tell it to give me a fraction, give me a fraction. It's not going to give you a fraction, guys, because pi goes on forever. It doesn't repeat. So do it like this. Go 45 times. If you definitely want to see that little fraction thingy, you can always do this. 1 over 180. Let's see if it gives it to me in fraction. And then just put a pi on the top. See? Pi over 4. I think you're doing too many steps by doing that. I would just go ahead, just go 45 divided by 180 immediately like this. Less buttons to push. And then turn it into a fraction. Make sure to put a pi in the numerator. Cool? Okay. So 60 degrees. 60 degrees times pi over 180. 6 goes into 18 3 times. So this one's 45 degrees was pi over 4. At 60 degrees is pi over 3. And then the 90 degrees, I would like for you guys to know that one. That's pi over what? 2. Pi over 2. How do we feel? Do we feel okay? All right. Look, guys, look at everything you filled in. Doesn't that look beautiful? Show it to your guardians or your adults. Maybe play this during dinner time in the dinner table in the background and have it as, All right, here we go. Turn the page. Some of you guys don't look very entertained. You guys are like, oh. Are you not entertained? Are you not entertained, Mujica? Okay. Here we go. Let's start. Here we go, guys. I'm going to go slow. 0 degrees. I'm starting at the x-axis, so this one's going to have to be 30. I'm going to add 15 degrees to the 30, so the next one is 45. I'm going to add another 15 degrees to the 45, so the next one is 60, and then I add another 30 because I'm going to an axis, 90. Are we shocked? Are we still okay? Okay. I'm coming from the axis, from the y-axis, so I'm going to add 30. What's 90 plus 30? 120. I'm going to add 15 to 120. What's 120 plus 15? 135. I'm going to add another 15 to the 135. What's that? 150. And then from 150 to this one, I'm going to add 30. So what's that? 180. We're doing good because that's the 180 one for sure. I add 30 again. What's that? 210. Add 15 degrees to the 210. 225. Add another 15 to the 225. 240. And then I'm going to an axis, so I'm going to add how many? So this is going to be 270. That's 3/4 of a circle. Good job. I'm going to add 30 now because I'm going from the axis. What's 270 plus 30? 300. Don't worry, I'll slow down so you guys can catch up. Add 15. Yeah, some of you already passed me, right? Add 15 to the 300. What's that? 315. Add another 15 to the 315. That's 330. And then add another 30. It should be what? And that's how you know that you did it correct, because one revolution is how many degrees? 360. All right, let's do the radians. I'm going to add the radians that we should all know immediately. Hopefully by heart you know this one. 0, pi over 2. What is it at 180 degrees? Pi. At 270 it is 3 pi over 2, and then 1 full revolution. 2 pi. We should know those by heart, guys. Know those automatically. All right. At 30 degrees, what did we say it was? Pi over 6. What did we say it was at 45 degrees? Pi over 4. What did we say it was at 60 degrees? Pi over 3. Okay. Let's see how we're going to do this. You can always take a degree and multiply by pi over 180, and you will always get your radian that way. Put your pencils down, guys, because I want you guys to take this in. I want you guys to really understand the mechanics of this. Yeah, put your pencils down. Don't worry, I'm going to give you time. So I'm going to tell you that this is, all right, just see if you can, give me your full attention, guys. I need it just for this one time. Well, I need it for a while, but for this one for sure. If you understand this, there's nothing that will ever stop you. You have good logic. You can go to medical school. Go be a doctor because you can understand how everything's connected. You just did reference angles. Miss Kyle, Miss Watson wants to see you. Sorry. Okay. We just finished reference angles. Yes or no? Do you agree that this angle right here, because look, you told me it's pi over 3. Do you agree that angle is pi over 3 from the x-axis to that ray or to that segment? Okay, so look at this angle here. This is my reference angle. Don't write this down, just listen. Don't worry, I'm going to give you guys time. Do you agree that that's pi over 3? Okay. No, that's just, I know, because I did it here instead of getting it close. Yeah. If it bothers you guys, let me go ahead and make it equal this. No, you're good. Let me see if I can make it there. Not quite perfect there. There we go. So there it is. Does that look like it's pretty good? All right. So, all right. The key that makes this work is this whole pi. All right, so think about it. I already took up 1/3 of a pi. What do you think this one in burnt orange is from here all the way to there if I've already taken up 1/3 of a pi? Yeah, you're close. What do you say? 2 pi? Not 2 pi. Look, this is 1/3 of a pi. From this x-axis, the positive x-axis, to the negative x-axis is a whole pi. So if I already took up 1/3 of a pi, what is the one in burnt orange? 2/3 of a pi. Do you see that, guys? So, yeah, tell me, say it. Yeah, if you add them together, it makes a whole pie. Do you guys see that? Mirales, do you see that? For sure. Okay, so check it out. What do you think if this reference angle right here is pi over 4, just like you told me over here? What do you think this angle is all the way to the 135 in radians? Yeah, 3/4 of pi, or 3 pi over 4. Do you guys see what we did? All right. This little guy right here, you told me over here in quadrant 1 that the little guy was pi over 6. There it is. So if this is pi over 6, what do you think from the x-axis all the way to 150 degrees is? Do you see the logic that you did? If you just use logic, you'll always get it right. Now go to 210. So this is my reference angle. That is another pi over 6. So a whole pi plus 1/6 of pi. 7 pi, you got to keep the 6. 7 pi over 6. See? Pi, turn it into a whole pi, so 6 pi over 6, and then add 1, 7 pi over 6. Do you see what we're doing? Take a guess. What do you think it is at 225 degrees? You keep the bottom as a 4. Because this, remember, this reference angle is pi over 4. What is it in the top? Not 3. 5. A whole pi plus 1/4 pi. A whole pi is like 4 pi over 4 plus 1/4 pi. Do you guys see that? Take a guess for this one at 240. The denominator, no, the denominator is not 6. The denominator is a 3 and 4 pi. See, because this is pi over 3 right here, that gap, that reference angle. Do you guys see what we did? All right, let's see if we can figure this one out over here. At 300 degrees, this gap right here, you remember, it's always with respect to the x-axis, not the y-axis. That is pi over 3. That reference angle is pi over 3. I keep calling it gap. So I'm pi over 3 away from a whole 2 pi. Pi over 3 away from a whole 2 pi. What is this then? 5 pi over 3. Is that what you said? Yeah, 5/3 pi. Good job. Job, how do you do it? Double the denominator, subtract 1 to get the numerator. Job, why are you doubling the denominator? If I double the denominator, double of 3 is 6. 6 pi over 3 is 2 pi. Do you guys see that? And I'm just subtracting 1. 5 pi over 3. So again, look, let's do the same logic. This gap here is pi over 4 at the 315. I'm pi over 4 away from 2 pi. The denominator is a 4. Double the 4. What's that? Subtract 1. 7 pi over 4. At 330 degrees, this little guy here, that reference angle is pi over 6. So, keep the 6. Double the 6. What's that? Subtract 1. There it is. Guys, okay. Real talk, where it comes down this weekend, real talk. Your memory will eventually let you down, especially if you're real tired and pull all-nighters. If you think critically, you will always figure it out. This is why math is beautiful. I know you guys have tricked a lot of math teachers into you thinking, I'm not trying to offend anyone. You've tricked a lot of math teachers by brute memorization because your memory is good, and someone has probably told you something similar, maybe not the unit circle, but something similar. Memorize this, we're going to have a quiz, and we're going to go over all of it. Don't worry, I'll come back. I know you guys are smart enough to memorize this, but you're working too hard. If you're going to memorize something, all you got to do is memorize the first quadrant. That's it. Memorize the first quadrant, and you're good. Chop. So then what do? Okay, you see that denominator 6? That stays in that pattern. If you reflect it, look, there it is, 6. Just subtract 1. For all of them, look, the denominator stays the same. Subtract 1, and you get the numerator. You get the numerator. The integer for the numerator. Does that make sense? In quadrant 3, you add 1. Chop. But why does it work? Because of the reference angle. This is 1/3 pi. This is 1/4 pi. This is 1/6 pi. And the difference between here and here, that gap is, that rotation is pi. So 1/6 away from a whole pi. So that's why it's 5 pi over 6. Do you guys see that? That's why this one's 3 pi over 4. That's why this one's 2 pi over 3. Because this reference angle is pi over 3, and you're 1/3 away from a whole pi. So 1/3 pi plus 2/3 pi is a whole pi. Cool or not cool? In quadrant 3, whatever the denominator is, add 1 for the integer. Make sure to put the pi on it. In quadrant 4, double the denominator, subtract 1 for the integer in the numerator. Do you see that pattern, guys? And you'll never mess up. Yay or nay? Okay. Now you can go ahead and write down. I know go. If you haven't written down the radians, go for it. Yeah, throw it. I'll catch it. I do want some chocolates. Oh, almond's my favorite too. No, it is. It is, Miss. Uncle Saz always has beef with me. I don't know what I did to her. No, I'm kidding, Miss. Nothing but love. All right, here we go. Ready? The coordinates at least know these 1 0 0 1. The radius is 1. Negative 1 0 0 negative 1. We're still okay, guys? All right, at 30 degrees, what did you tell me that coordinate was? The square root of 3 over 2. You said 3 squared. Square root of 3 over 2 for your x, 1/2 for your y. At 45 degrees, or pi over 4 radians, what was my x and my y? Square root of 2 over 2, and both were the same. At 60 degrees, or pi over 3, what did you say was my x and y, or the ordered pair? 1/2. Perfect. All right, guys, you don't have to memorize anything. In quadrant 2, just reflect those numbers, and the only difference is that the x's are negative, right? Because in quadrant 2, the x's are negative, and in quadrant 3, they're both going to be negative, and in quadrant 4, only the what coordinates? Only the y's are negative. Do you guys see that? So there it is. Just reflect them. So here it is. At 120 degrees, the x is negative, so put negative half, square root of 3 over 2. At 135 degrees, the x is negative, so put negative square root of 2 over 2. Square root of 2 over 2. Yeah, I know. Next year I'll make the parentheses larger. At the 5 pi over 6, or the 150 degrees, the x is negative, so negative square root of 3 over 2. That's a 3 there. Comma, 1/2. Let me make the negative better. Negative square root of 3. Okay, there it is. I'm going to go to the 210, or the 7 pi over 6. Just reflect it again, and they're both negative. The x is a negative square root of 3 over 2. Negative 1/2. At 225 degrees, negative square root of 2 over 2, negative square root of 2 over 2. At 240 degrees, negative 1/2, negative square root of 3 over 2. Are we still okay, guys? Okay, at 300 degrees, what's my x coordinate? Which one is it? 1/2 or square root of 3 over 2? Yeah, 1/2. Be brave, guys. Be brave. This is a safe space. Negative square root of 3 over 2 for the y coordinate. Square root of 2 over 2. Negative square root of 2 over 2 for at 315 degrees. At 11 pi over 6, square root of 3 over 2. And negative 1/2 for the y coordinate. Are we okay? Did all that make sense, guys? Okay. Don't worry, we're almost done. Tomorrow, and okay, I don't want anxiety, so don't have anxiety. Don't study. Tomorrow we're going to have a quiz. It's a practice quiz. Relax. It's not going to go in the grade book. Don't study. Just go cold turkey. If you get it's not going to go on the grade book unless you get 100. If you get 100, I'll put it on the grade book. The first, I can't remember the number I told first and fifth. The first 4 or 5 quizzes are not going to count. Every day from now on for the next 2 to 3 weeks, actually probably 4 weeks, we're going to have a quiz. The timer's going to set at 10 minutes. And you have 10 minutes it's going to look like this. Chop, how's it going to look? It's going to look exactly like this page right here. And you're going to have to tell me what each number is without a calculator. And relax. By the time you take it 3 or 4 times, you're going to notice you're going to start coming really close to 100. If you don't get really close to 100 and something's going on, that means you're a robot coming after school. We'll see if we can... nothing's wrong with you. I'm not going to say we'll see if we can fix you. Nothing's wrong with you. But we'll see if we can get you like thinking critically. You know what I mean? Okay. Oh, there is another announcement. Remind me about a UH quiz before we set you guys totally loose. Maybe some of you already know. All right. So how do we analyze something like sine of 150? Well, back in the day, by the way, how many of you have done this already with like prep or something? Or is this all brand new material for everyone? Okay. So check it out. My calculator's in degree mode. I'm going to push sine of 150. You're not going to have a calculator on the quiz. If you had a calculator on the quiz, you can just do this all the time. And then look, sine of 150 degrees is just half. So I'm going to come over here and I'm going to write, oh, sorry, that's an email. I'm going to come over here and I'm going to write sine of 150 degrees equals 1/2. Yeah, I'm gonna show you how to do it right now. It's 150 minutes. It's just that I write so fast. It just All right. How do we do it? Look at page 2 of your notes. Look at the very, very top. Remember when we first started and I told you guys to circle these things? Look what it says up here that sine theta is. It says sine theta is always your what value? The y. Bless you. Bless you squared. I heard someone sneeze. It says here that cosine theta is always your what value? What value does it say for cosine theta, Mr. Hernandez? Or Gonzalez, sorry. X. And for sine theta, it says that it's going to be what? Y. So when it says sine of 150, I go to 150 degrees and I look for my y coordinate. So go to 150. So here's my 150. And what's my y coordinate at 150? 1/2. Do you guys see it? And that's how we got the 1/2. Yeah, I'm going to put a blank unit circle in the back. A blank one. Yeah, we can. You know? Well, because you can fill it out. I'm not going to count the unit circle as a 10th grade. I'm going to count this. All right. Yeah. You got 10 minutes. Yeah. I think in the beginning I give you 15 minutes, but then at the end time is 10. So it's plenty of time. Trust, guys. I've been doing this for a while. Look, trust. Look at all the trust. Okay, here we go. You guys ready? Sine of 60. Look, check it out. Hey, Miss Kyle, can I bother you for like 5 seconds? What's sine of 60 degrees? You're close. Let's see it. Square root of, square root of 3 over 2. Look, cold turkey. And I bet you if I would have told her in advance that I was going to ask her that question, she would have definitely prepared and gotten it cold turkey. Bam. All right, so now let's see you guys. Go to 60 degrees. What is my y value at 60 degrees? Square root of 3 over 2. Where to go, Miss Kyle? Where to go, Miss Esquivel? Where to go, Miss Alcoces? Tan of 315 degrees. Go to 315 degrees. Tan is what over what? Y over x. So I go to 315 degrees and I'm going to go negative square root of 2 over 2 divided by square root of 2 over 2. This is an okay answer. I want a better answer. Negative 1. Because see, it's the same magnitude of both of them. One's negative, one's positive. Negative divided by positive is a negative. Do you guys see that? Right. Cosine of 330. Go to 330 degrees. At 330 degrees, what is my x value? Square root of 3 over 2. Cosine is the x. Chop. Why is cosine the x? Well, come over here to page 2. Look what it says. Cosine theta is your x. Are we seeing that, guys? All right. There we go. That's cosine. Go to sine. Sine of 180. I'm going left to right. Go to 180 degrees. What is sine of 180? It's a y value. Yeah, be brave. It's okay. It's a safe space. What is it? 0. Cosine of 90 degrees. Go to 90 degrees. What's the value? 0. Cosine's the x. Sine of negative 30. Child, there's no negative 30 in the unit circle. Let's go to the unit circle. So negative 30. I'm going to write it right here in black. Negative 30 degrees, guys. I would have gone clockwise. There it is. So negative 30 degrees and 330 degrees are coterminal. There's that word again, coterminal. It creates that same segment. Here's negative 30. So what was it, cosine or sine? I already forgot. Sine. What is sine of negative 30? Negative 1/2. Do you see what we're doing, guys? Sine of 270. Oh, you don't see what we're doing? Okay. Sine of 270. Go to 270 degrees. What's sine of 270? Negative 1. Sine of negative 120. Chubb, I don't know where that one's at. Okay. It's a rotate. Okay. Time out. Put your pencils down because this is a common error that I see. You guys like to reflect. Be careful. I guess on this one it would have worked. But you got to, okay. The rotation of positive 120 would have been that one. But go the same distance, the same rotation, but clockwise. So the same rotation, it's this one in green. So negative 120 is the same thing as 240. Do you guys see that? Those are coterminal. Okay, now you can put your pencils back up. So I already forgot what was the question. Sine of negative 120. So what's sine of negative 120? Negative square root of 3 over 2. Negative. There it is. Cool or not cool? tan of 120. Y over x, go to 120. Y over x. So I'm going to write square root of 3 over 2. That's a positive y. And the x is a negative 1/2. That's an okay answer. A better answer, the 2's cancel out. Negative square root of 3. If you put this answer here, I would count it correct because that's still correct. Yeah, I have a lot of kids do that. They're like, I'm not going to bother simplifying. I'm just going to put the y coordinate and the x coordinate. Yeah, if you want to do that, that's fine. For now, it's fine. Later on, they're going to have to, but right now we're rookies, so it's fine. Don't get mad, miss. You got mad real quick. All right. These are radians. It's the same as degrees. These are radians. It's the same as degrees, guys. Sine of pi over 3. Go to pi over 3. It's the same as 60 degrees. At pi over 3, what is sine of pi over 3? Square root of 3 over 2. Tan of 7 pi over 4. You go to 7 pi over 4. That's in quadrant 4. And it's a y divided by x. So I'm going to go negative square root of 2 over 2 divided by square root of 2 over 2. Negative divided by a positive is a negative, so it's going to be negative 1. Yay or nay? Okay. Oh, by the way, we're going to do unit circle quizzes in your class too, in calculus also. We have to. Don't worry, the first 3 will be, cosine of 11 pi over 6. What is that? Square root of 3 over 2. Good job. Sine of pi. Go to pi. What's sine of pi? 0. Cosine of pi over 2. 0 again. Sine of negative pi over 6. Go clockwise. It's like negative 30 or 330. Yeah, negative 1/2. Sine of 3 pi over 2. You probably already saw. I just put the same angles. Sine of 3 pi over 2 is negative 1. Sine of negative 2 pi over 3. That's the same as negative 120. Negative square root of 3 over 2. You're in quadrant 3. Cosine of 2 pi over 3. The y value is square root of 3 over 2. The x value is negative 1/2. You can leave it like that if you want, but the better answer is negative square root of 3. Oh, did I mess up somewhere? Yeah, ask me, guys. Can we go over which one? Negative pi over 6, yes. This is, okay, pi over 6 would have been this one. See the pi over 6 is there? Negative pi over 6, you go clockwise. That's negative pi over 6. So negative pi over 6 is the same thing as 11 pi over 6. You see it? The 2 pi over 3? Oh, it's not tangent. Yeah, how come you guys didn't tell me? I make mistakes all the time. I was looking at this one. See, okay. Cosine of 2. Yeah, see, tell me, guys, I make mistakes. I'm going to edit it on my video so it doesn't look like I made a mistake.
That was on purpose.
Yeah, that was on purpose. Cosine of 2 pi over 3. What is it? Negative 1/2. You were right. I was wrong. I was testing you guys. Okay. Sorry, guys. Look, and that's what we were talking to. So you will be fine. Well, okay. All right, guys. No, you don't have to memorize. Guys, Guys, there's a way to do this. There's a way to tackle this that you don't have to worry. Work smarter. Yes, look, I've seen you guys do it where you just blatantly just memorize every single detail. Work smarter. Look, all of the cosines pi over 6s, all of them are square root of 3 over 2. The only thing you got to think about it is it positive or negative? Chop, what are you talking about? Cosine of pi over 6, square root of 3 over 2. Cosine of 5 pi over 6, negative square root of 3 over 2. Cosine 7 pi over 6, negative square root of 3 over 2. Cosine 11 pi over 6, square root of 3 over 2. Chop, how are you doing this? You're a genius. No, I'm not. This is how I'm doing it. Let me tell you. I'm going to show you all the secrets. When I hear cosine pi over memorize this. Quadrant 1, memorize it. Yes. When I hear cosine 5 pi over 6, in my head, I'm like, 5 pi over 6. Oh, there's a 5 on the top. Oh, I'm in quadrant 2. So remember what we talked about earlier? This is pi over 6, my reference angle. So 1/6 of pi minus pi, that's your 5/6 of pi, or 5/6 pi, plus 1/6 is your whole pi. I'm just talking about the radians. Like, remember how we got that radian? Like, we said this, okay, let me go slow. I know, let me go slow. Bring it over here. Blah, blah, blah. Remember, we said this was pi over 6. So then we said, well, then how much is this rotation from way over there if this is 1/6 pi and from here to here is a whole pi? Then we said, well, that must be 5/6 pi. And that's how we got that radian. Okay, now when I hear cosine, I'm thinking, that's my x value. And then when I hear 5 pi over 6, I'm like, oh, my x value in quadrant 2. My x value in quadrant 2 is negative. All the cosines of pi over 6 are always square root of 3 over 2. That's always your x value. But I'm in quadrant 2, so it must be a negative. If I say cosine of 7 pi over 6, oh, 7 pi over 6, that's quadrant 3. Oh, it's a pi over, I have a 6 in the denominator, 7 pi over 6. So it must be a negative square root of 3 over 2 for the cosine. Negative square root of 3. Yeah, I know. Look, let me write it, because I think you guys are visuals, so you guys need to write it. All right, so let me say, I'm going to write it right here. So look, there's a blank space. So cosine pi over 6. Know this one. Know that one is square root of 3 over 2. You got to know that. So memorize that. All right. And I know you guys are visual, so you guys are probably going to want to fill in the unit circle anyways. All of these, do all these have a denominator of 6? Okay. As long as, look, this one, the integer, the numerator has a 5 in it, 5 pi over 6. So that must mean I'm in quadrant 2. So this must be a negative square root of 3 over 2. Okay. This one has a 7. So that must be in quadrant 3. Everything in quadrant 3 is negative. So this must be a negative square root of 3 over 2. This one has an 11. I must be in quadrant 4, because I'm pi over 6 away from quadrant 4. So this must be a square root of 3 over 2. Of course, you can always just look at the unit circle, right? Don't worry, I'm going to go back to it. 5 pi over 6 cosine, oh, there's that negative value. 7 pi over 6 cosine, oh, it's this negative square root of 3 over 2. 11 pi over 6 cosine, oh, it's this one right here. You can always do that. I'll have a unit circle printed for you in the back. But be smart, like start, the way, by the way, the way the brain works, it's very similar to the way memory works in a computer, right? The stack and pop, if you have programming languages, okay, if you understand how to program. Okay, how do we feel? Do we feel okay? I know it's a lot. We did a lot, guys. We have 2 delta maths, one that's due today and one that's due tomorrow. Don't worry, tomorrow you'll have all the, if you have an extension if you have something called a 504 or whatever, don't worry, we're gonna oblige and just let me know and we'll give you an extension. We got you. If you're going through something, let me know. If you're having trouble, like, man, I just don't get it, let me know. We're not gonna penalize you. You just gotta let me know, guys. I can't read minds. So if you don't let me know, I don't know. I just count it, the penalty. All right. One last thing. There's something called, I'll write it right here. UH, right triangles and sectors. If you go to Gradebook, it's already on there. It's already on there, like, for you to take, right? So if you log into UH, look for this quiz. It's going to be due on Wednesday for everyone. Due by Wednesday, 08, and I already forgot the date. What is the Wednesday? 27th. Okay, 08/27. Here's how the UH works. You know how on Delta Math you can ask me questions and I'll help you with the Delta Math on the spot? With UH, you cannot ask me questions on the spot, because the way UH works is if I give you the answer for UH, I'm giving you the answer for the quiz. So does that make sense? So I can help you, but only once you submitted it. You can take, right now it's set up where you can take it as many times as you want. I put the highest grade in. So if you take it 10 times to get your 100, there it is. You took it 10 times. Don't ask me questions initially. Ask me questions once you've taken it. All right, so here it is. On Monday, on Tuesday the 26th, I'm going to have an overview after school. 3's a crowd. As long as there's 3 of you, I'm going to do it. I'm going to do the overview. I'm going to take one of y'all's quizzes. There's already, first period and fifth period, some of them have already taken them. I think the highest grade right now is a 90. I'll probably print that one out unless I see 100. And I'm going to go over the questions after school. Do you have to come? No, you don't. I'm going to record it, but it would be good. It would be beneficial if you did come, so that way you can ask questions. Does that make sense? Okay. So there it is. You don't have to take it now, guys, the UH, but when is it due? It's due Wednesday. Is that plenty of time to get 100 between now and then? On Tuesday after school, we'll have an overview. If you're having trouble, come in Tuesday after school. Cool or not cool? We'll start at 4 o'clock, so you have a 15-minute break between when the bell rings and when we start class, when we start after school. Are we good, guys? All right, log into Delta Math, take care of the two deltas, and let me know if you have questions.